All right, hello guys. Welcome to your first video over inequality. So what we're going to talk about today is section 3-1, writing and graphing inequalities. Now you should know what an inequality is. You have probably definitely encountered several of the inequalities, less than, greater than. I know you know what those mean. But we're going to talk about all of the inequalities today and make sure you know how to write inequalities, how to graph inequalities, because that is where we're going to be going next. So if you look at the screen, the first inequality that you see is the inequality less than. Okay, so you need to know when you see that symbol that that means less than. Okay, what's the next one? The next one is greater than. Okay. Now, if we look at the next one, you might ask, how is the third one different than the first one? Okay, well, the way that those are different is in this little symbol right there, that little line. Okay, the line underneath the less than symbol means equal to. So what this symbol means is less than or equal to. So when we have the line underneath an inequality symbol, that means equal to. Less than or equal to. So what do you think the next one would be? Exactly. Greater than or equal to. Definitely need to write these down. And then the last one. It looks like an equal sign, but it has a slash through it. Okay, so that means not equal to. Pretty simple. Not equal to. All right, so make sure you know each of those symbols. Don't get the less than and greater than mixed up. Okay, some people have a tendency to do that, so make sure you have a way in your head to tell the difference between those two. All right, so if I gave you the following inequalities and asked you to describe the solution to each of these in words. Okay, so if I read the first one, I read A is less than or equal to 4. So A can be any number that is less than or equal to 4 would make that true. So all real numbers less than or equal to 4. So different numbers that would make this true would be the number 3, the number -10. Would the number 4 make that statement true? Yes, 4 is equal to 4. So because of that line right there, 4 would also make that true. Okay, how do you think I would read the next one? A is less than 1. All real numbers would make that statement true that are less than 1. So would the number 1 make that true? Is 1 less than 1? No. 1 is equal to 1, but this one does not have an equal to line underneath the inequality symbol. So you can only be numbers less than 1. Example 0, -100, -5/7, etc. Okay, the next one. All real numbers greater than 2. And finally, the last one, what would that one be? All real numbers greater than or equal to 16. So we have numbers 16 and on. Greater, 16, 17, 18, and everything in between. All right, now I'm going to take these inequalities on this page, and we need to know how to graph these, how to represent these inequalities on a number line. How do we represent the solutions on a number line? Okay, well, there's something very, very important, and I would absolutely write down all of these steps and the difference between these two circles that I'm about to talk about. There are two important circles that we're going to use, or dots, points, when we're graphing an inequality. And that is an open circle, okay, which is this one right here. We call this an open circle. And this is a closed dot, or closed circle. Okay, open meaning it's not colored in, closed meaning it is. Okay, so these are the steps we're going to take to graph something. So hopefully you've paused the video, written it down, and then join us on the next slide. Number 1, to draw a number line. Number 2, label the critical point. The critical point is this number right here. These are the critical points, the numbers that are in our inequality. So we're going to label the critical point. We're going to choose a number smaller and larger than the critical point to include, and that's going to be on our number line. I'll show you an example and this will make more sense. We're going to decide if our dot's going to be open or closed, decide which part of the number line to shade, and then we're going to test what we have drawn and see if it's correct. Okay, open, back to open and closed dot. Open dot simply means that that critical point is exclusive. It is not included in the solution set, whereas inclusive means it is included. That critical point is part of the solution set. Okay, so what we're going to notice is that we use an open dot anytime we have a less than or a greater than symbol. Less than or greater than symbol, we're going to use an open dot. If we have a less than or equal to or a greater than or equal to symbol, we're going to use the closed dot. So let's practice some of these. I have t is greater than or equal to 15, and I want to draw on a number line all the values that make that true. So my critical point is 15, so I put that down. Sorry, that's supposed to be a little tick mark, but you guys know how my smartboard is. 15 in the middle. Now I need to choose a number smaller and a number larger at the minimum to include on my number line. Okay, so some of you might be used to drawing number lines that have a ton of numbers. Others of you, I think this is fine for what we're doing. Okay, so now I need to decide, I want to show all of the values that are greater than or equal to 15. So is 15 included in my solution set? Does 15 make this statement true? Yes, because 15 is equal to 15. Therefore, I want to use a filled in dot. Okay, now this is supposed to be on my number line. Okay, so I have a filled in dot because 15 is included in my solution set. And I also want to include all of the values that are greater than 15. So would that be 14 or would that be 16? That would be 16. So I'm going to shade, again, you have to bear with me, this is supposed to be on that line, and it's really hard to guess where that's going to be. I'm going to shade the whole right-hand side of my number line. Okay, now in the steps that you just wrote down, it said to take a test point and see if it's true. So I'm going to pick the number, like let's say 17, because 17 would be over here. Would 17 make our inequality true? Yes, it does. 17 is greater than 15, so I know that what I shaded was correct. What I did not shade, like the number 13, is 13 greater than or equal to 15? No, so 13 should not be shaded, and it's not shaded, so that's good. Now let's look at the next one. 3 squared is greater than or equal to w. Well, I know that 3 squared is just simply 9, so I have 9 is greater than or equal to w. Now if I want to rewrite that with the variable on the left-hand side, just because to me it makes it easier, this would be w is what? Is w less than or equal to 9. Now that's hard for a lot of students to figure out how to write that, okay? The way I always kind of look at it, see where the point is? The point is facing the w. So when I rewrite it, the point still needs to be facing the w, okay? Or another way of looking at it, the mouth is open to the 9. When I rewrote it this second time, the mouth is still open to the 9. So I know I've rewritten it correctly. Now my critical point, that's the first thing I need to label, is 9, a number smaller than 9, a number larger than 9. Now I need to decide if I'm going to use an open or closed dot. Okay? Is 9 included or excluded from my solution set? If I plug in 9 into w, do I have a true or false statement? Is 9 less than or equal to 9? It's true. Therefore, I'm going to use a closed dot. So I have a closed dot on 9 because 9 is included. And I want everything that is less than or equal to that. So do I want 8 or do I want 10? I want 8. So I shade everything to the left, meaning all the numbers on a number line that are less than or equal to 9 are true. So that would be like the number 7, the number 6, the number 5, and so on. All those numbers are true. Is the number 10 true? If I plug in 10 into my inequality, is it true or false? Is 10 less than or equal to 9? No, so 10 should not be shaded. All right, last one. B is less than 3 minus 10. Well, I know that 3 minus 10, that's just negative 7. So I have b is less than negative 7. That's my critical point. Goes on my number line. A number that is smaller than negative 7 would be like negative 8. A number that is bigger than negative 7, negative 6. Okay, now let's decide, open or closed dot. Is negative 7 going to be included in my solution set? Is negative 7 less than negative 7? No, it sure is not. It's equal to negative 7, but I don't have an equal to sign. So this is not true. Therefore, I use an open circle to represent that. So on my critical point at negative 7, I have an open circle. And I'm going to be shading to the left because I want all the values to be included that are less than negative 7. Okay, let's make sure I'm right. 0, over here would be 0 somewhere. If I plug in 0, 0 less than negative 7, is that true? No, 0 is greater than negative 7. So 0 should not be shaded. Is it shaded? No, because this is the part that's shaded. So we're good to go. All right, now let's look at it in a different way. Now I'm given the graph, and I want to write the inequality. So I can choose any letter I want. I'm going to choose x. X is, now I need to decide if I want less than or greater than. If I know my critical value is 2. Now, did they shade numbers that are smaller than 2 or numbers that are greater than 2? They shaded numbers that are smaller, so I'm going to use a less than sign. Now, the only other thing I need to remember is, am I going to have that equal to line there or not? Am I? No, because I have an open circle. Open circle, you do not have an equal to line. It's not inclusive. It is exclusive. So x is less than 2. All right, a couple more to finish this up. We're going to read these word problems and then write our inequality and graph it. To enter the play area, children must be more than 4 feet tall. Children is my variable. They have to be, or it's really their height, okay? Their height has to be more than 4 feet. So what inequality do I use to represent more than 4 feet? Greater than 4. Can it be greater than or equal to? Can the child be exactly 4 feet? Can they be equal to 4 feet? Nope. They have to be more than 4 feet. So I just wanted to simply say C is greater than 4. Now you guys go ahead and draw a number line and graph that for us. All right, once you finish graphing it, let's look at the next one. As of July 1988, the speed limit on rural interstates in Virginia is 65 miles per hour. So we're talking about a speed limit here. That means I know a speed limit tells me I can go that speed or I can go less than that, right? If the speed limit's 65, could I write out exactly 65? I really could. As long as I don't go up to 66, I'm pretty safe. So I know that my speed needs to be less than, or it could be equal to 65. Does that make sense to you? Hopefully so. Let's draw it on a number line and see what your solution set would be. All the different numbers, that would tell you, once you have it graphed, all of the numbers that you could drive at in order to be safe. All right, so that's it. See you guys later.